In this video, we're going to work through all the parts on question number 6 from the 2.7 MyLab Math homework on marginal analysis. So in question 6, we're given a price-demand equation and we're given a cost function. So we have our price-demand equation right here. There we go, price-demand equation, and our cost function. And we're told that for both the equation and the function, X is the number of saws that can be sold, so that's a demand, at a price of P dollars per saw. And capital C of X is the total cost in dollars for producing X saws. Okay, so we're going to be coming back to this information that's given to us in our prompt over and over again. But let's start here with part A. Part A asks us to express the price P as a function of the demand X. So we need to go to this price demand function right here. Okay, so let me rewrite it. So X equals to 12,000 minus 40P. And again, X is the number of saws that can be sold at a price of P dollars. And of course, P is going to be the dollar amount that each saw is sold for. So P is the dollar amount per saw, but that price is at the demand of X saws. So that X and P are connected together. P is the price for demand level of X saws. X is the number of saws that can be sold at a particular price P. So this equation relates those two things. So we can write it either way. Right now, the way it is written, if I know the price P and I plug in a dollar amount there and I follow this rule, it's going to calculate the related number of saws that we sell at that particular price. And that's okay, but we're being asked to solve for P. We're being asked to express price as a function of demand. So right now, this is an equation. It's not in function notation, but if I did write in function notation, it would look like this. Instead of f of x, that's our default function notation. What's happening here? We're calculating demand if we can input the price. If we know the price here, if we know that dollar amount and we follow the rule, we calculate the demand. So if I was going to write this in function notation, this would be a demand in terms of price. Now they're asking us for a price as a function of demand. So they want us to just basically solve for P. And I'm going to get an expression over here that involves an X. And then if I know the X value and plug it in and follow the rule, it'll calculate the related price. So algebraically, all we're doing is just solving for P. So let's go ahead and do that. I'm going to rewrite the original equation that was given to me here. So my original equation was X equals 12,000 minus 40P. I'm just going to solve for P. So I'm going to subtract 12,000 on both sides. And then once I've done that, I'm going to divide both sides by negative 40. Now, when you're dividing both sides by negative 40, technically, if I just stop right here, P equals this fraction, I'm done. I've solved for P. But later, when we try to use this to construct a revenue function and later find the derivative of that revenue function, working with this fraction is going to be kind of yucky. So what we're going to do is take each term of the binomial and divide it by negative 40 individually. So X is going to be divided by negative 40 minus 12,000 is going to be divided by negative 40. And there's an understood 1 in front of that X. So my calculator, I'm going to type 1 divided by negative 40, and I'm going to convert that fraction over into a decimal. And when I do that, I end up getting a negative 0.025x. And then I'm subtracting a negative amount over here, so that turns to plus, and that would be 300. Okay, so we've written this function. I've rewritten it to be a P equals function. I know the price if I follow this rule. Negative 0.025x plus 300. So if I know the x value, if I know the number of saws, and I plug in number of saws, and I follow this rule, it's going to calculate the related price. So if I wanted to write this in function notation, it would be calculating the price if I input a number of saws. So P of X, where X is the number of saws. And if I input that into the rule and I follow this rule, it calculates the price the dollar amount per saw at that demand level. Okay, so this is what I would enter in for part A. So let's go ahead and do that. I'm going to hop over here to my math lab now. Oh. Okay, here we are in my math lab. I think that's what I got. I don't know. I mean, your numbers will be different in your actual question. These are the numbers I was given, but that process will be the same. So I'm going to press check answer. I'm going to press enter. I don't know. Am I right? Yay, I got that one right. Okay, so that's A. And then it pulls up B here where we're being asked to state the domain of this function. Now, since we got a little behind in class, I will provide the domain on test 1. I will not require you to find it, but it's something that's going to come up again in the future, and it's really not that bad. So I'm going to show you how to find the domain of the function in this video. So let's do that. Okay, so just a reminder, we just found this price demand equation. I'm writing it in function notation here. Okay, we just found that in part A. And remember, domains are just restrictions on what we can input into a function. Now, if this wasn't a word problem, my domain would be all real numbers, right? So remember, what does X represent? X is the number of saws here. But if it was just random function, X could be anything. But this isn't. This is a real world situation. So there's some restrictions on X. So if X is representing the number of saws that are produced and sold, that number cannot be negative. So I automatically know that one of my domain restrictions on X, which is the number of saws, is that X has to be positive. So I'm going to say X has to be greater than or equal to 0. I mean, it could be 0, right? I mean, you could sell no saws. So I'm going to put greater than or equal to 0 there. So automatically answer choice B and C are out. So it's either going to be A or D. And then what's something else I know here? I need this upper restriction. So again, if this wasn't a real world scenario, then my X could be anything. It could go to infinity, but it's not. It's the number of saws. I can't make an infinite number of saws. There has to be some upper limit, some maximum amount of saws that I can make. And what we're going to do is come over here to this price demand function, because something else I know is that price can't be negative. If price was negative, we'd be in trouble, right? That means our company would be giving things away plus like a saw with cash attached to it. So that's not going to happen. So we're going to assume that the price must also be greater than or equal to 0. Now, if the price is actually equal to 0, it means they're giving it away for free, right? So that, like in the real world, probably wouldn't happen, but could it be free? It could. So it's going to be part of the domain. So basically what I'm doing is I'm just going to take my price demand function in terms of price, which I have right here, and I'm just going to set that equal, greater than or equal to 0 and solve that inequality. So I'm just taking what P equaled, and notice there's an X in it because I'm trying to restrict my X input in this domain. So my X expression there, greater than or equal to 0. So I'm just going to subtract 300 on both sides. Okay, I get negative 0.025x greater than or equal to negative 300. And I divide both sides by that negative decimal amount. And you have to remember from algebra, when you divide both sides by a negative number in an inequality, it flips the direction. It reverses the direction of that inequality sign. So I get x must be less than or equal to, I don't know, I'm typing that in my calculator right now. I get 12,000. Okay, so that's the upper limit. That's the maximum number of saws that this company can make and sell in this market. So my upper restriction on my domain is 12,000. So I'm going to enter that in D. Okay, so now we're kind of switching gears here. Part B is asking us to find the marginal cost. Now, if I had my choice, I would have either put this at the very beginning, because if we're finding the marginal cost, all we need to do is go to that cost function they gave us up here. It had nothing to do with the price demand equation. It's completely separate. So here for part A, we just spent all this time dealing with this price demand equation and its domain and all of that. And we're going to need to know all of that information to build our revenue function later. And I don't know, maybe part C or something, but right now we're ignoring everything we just did in A, and we're going back just to our cost function, and we're just taking the derivative, because remember, marginal just It's telling us how the cost is changing, and that's a rate of change, which is a derivative. And all we have to do here is our power rule. So when I take the derivative of a constant number, that's 0. So I don't need to write that. And then I take the derivative of 60x, that's just 60. If you wanted to use your power rule, you'd have to write the understood 1 exponent, multiply it with your coefficient, so 60 times 1 is 60, rewrite your base, and then decrease the exponent by 1. But x to the 0 power is just 1, and 60 times 1 is just 60, so we don't really need to write all that. But you can if you want. So there we have our marginal cost, so I'll go ahead and type that into my MATLAB. Okay, so I went and entered that in my MATLAB, and it doesn't ask us to interpret that, but I want to just for a quick second. How would we interpret this marginal cost being 60? Like, what is that even telling us? Now, you just have to remember, derivatives are rates of change. So rates of change compare how two quantities are changing in relation to each other. So I need to make the 60 into a fraction. And then I have to remind myself that, derivatives are slopes. Slopes are rates of change in y values over change in x values. So it's your change in your outputs over your change in your inputs. So what was my output calculating? It was total costs in dollars. So this unit up here on the 60 is going to be dollars. And what was I inputting? What did X represent again? My input was the number of saws. The number of saws being made and produced. So what this marginal cost is telling me is that total costs are increased by $60 per saw. So $60 for each additional saw. Our total costs are increasing by $60. And that's a constant. It doesn't matter what my input is. Doesn't matter what I input in here, my rate of change is always going to be $60 per each additional saw. No matter what my production level is, it doesn't matter how many saws I'm making. If I make another saw, it's going to cost me $60. This is what that marginal cost is telling me. Okay, so now let's go down here to C. That was the next question that we're actually asked. I just kind of made up that other part here, but C is asking us to find the revenue function and state its domain. So let's do that. So on test 1, you'll be given this formula. You'll be given R of X equals X times P. So remember, revenue is all the money the company is bringing in on the sale of a certain number of items, right? So how does the company make money? It sells stuff. And remember, X is the number of saws that are being made and sold. And P was the price per saw. So if X is how many things I sold and P is how much each thing costs, when I multiply those together, it gives me the revenue. But I'll provide this formula for you. Reading the input value is what's going to help you here, because this revenue function is a function of X. So I need my rule to have an X in it, not the P, but that's okay, because think back to what we did in part A. In part A, you solved this price demand equation. Instead of making it say X equals, you made it say P equals. And when we did that, what did we get? Oh, it's right here. Okay. We got P is equal to negative 0.025X plus 300. So I can replace this P with an expression that involves an X. So my function will be all in terms of the number of saws. So when I construct this revenue function, I'm going to have X times P, which is that expression that we got up in part A. Now, if you'd done it the other way, if you had tried to use this formula and you kept the P and you took this X equals and plugged it straight in there where your X was, let's look at what that would end up with. If I replace the X with the original equation they gave me up there, it's fine. It's totally legal to do this algebraically, but now I can see that my revenue function is set up to input number of saws, but my calculation doesn't have any X's in it. It just has prices. So my input variable is not matching the variable used in my function rule there. So I don't want to do that. But now if I input my number of saws here, my function rule has X's in it. So I have numbers of saws in my rule. I'm inputting number of saws. It all works out. So this is my revenue function. I can leave it as is, but it's probably more helpful to go ahead and distribute that X to both terms of that binomial. And then we'll be set up to find marginal revenue really easily just using our power rule. So I'm going to go ahead and type this in as my revenue function. So now that we have that revenue function entered into my MATLAB, it's asking us to find the domain of the revenue function. So we're being asked to find the domain of this revenue function. Now you actually don't have to do any work for this because you constructed the revenue function by multiplying x times p. And P already has a restriction on its domain. So that domain automatically restricts my revenue. So it's actually the same domain there. So I'm going to select B and I'm going to plug in 0 and 12,000. So if my price demand function only works between 0 and 12,000 saws, and I use that price demand function to create a revenue function, the revenue function is also restricted by that domain. So the revenue function is only valid between 0 and 12,000 saws. Okay, now D is just asking us to find the marginal revenue. So we're going to come back to that revenue function, and we're just going to use our power rule to find the derivative of that. Okay, so when I use my power rule, I put the prime there. This is just my revenue function. Now I'm using my power rule, so I'll put my R prime there. Okay, and again, your power rule just says you drop the exponent down to the front, multiply with that coefficient, and then decrease the exponent by 1. So when I do that, I'm going to end up with a negative 0.05 x to the first, but we don't write the understood exponent 1 because it could look like a prime. It's just that. And technically we're multiplying by the derivative of the base if we're doing our chain rule, but the derivative of x is just 1. So we're not going to write that down there. Plus, then we have 300x. The derivative of that is just 300, or you can follow your power rule. Understood exponent of 1 times a coefficient of 300. 300 times 1 is 300. Rewrite the base, decrease the exponent by 1. But again, x to the 0 power is just 1, so we don't need to write that. Technically, we're multiplying by the derivative of the base, but that is also just 1, so we don't need to write that. So we end up with just 300 there. Okay, so that's our marginal revenue. And then once we enter that, y'all, I totally just got this wrong on my MATLAB because I typed in R prime of x equals and then the derivative, and they didn't want me to type the R prime of x. I was just supposed to type the expression. So we got the derivative right. I just put too much information in my answer, but it's essentially the same thing. So our calculus was good. And again, if something like that happens to you on your homework, you can always just click Ask the Instructor. It'll email me your problem with your numbers, and you can just explain what happened, and I can overwrite that for you. Because I know that's frustrating when that happens. Okay, so now here comes the interpreting part. So we're being asked to interpret R prime of 2,100 and R prime of 4,500. So I need to input 2,100 into this rule that we just got in part D for the marginal revenue, and I'll get an output, and then I'll interpret it, and then I'll do the same thing. I'll input 4,500 into this rule, get an output, and interpret it. So let's do the 2,100 first. Okay, so I just took my rule, my marginal revenue rule, but I wrote it in function notation because then we're wanting to input 2,100 saws into my revenue function. So the function notation makes more sense there. So I just plugged in my 2,100 and I put this in my calculator and I got 195, and it's positive. So what does this tell me? This tells me at a production level of 2,100 saws, if I make and sell 2,100 saws in this market, I would expect my revenue to be increasing. It's increasing because this is a positive number. But the units here are what really trip people up. So you have to remember a derivative is a rate of change. It's a slope. You have a rise over run. You need to put your units for your output with the numerator. You need to put your units for the input with the denominator. So revenue, think back to your revenue function. When you input number of saws into your revenue function and you follow the rule, you're getting a dollar amount out. So my output is $195 per my input was number of saws. So my revenue is increasing $195 per each additional saw that is made and sold. And that's only happening at a production level of 2,100 saws. We'll see later when we up our production level, it's going to change how our revenue is reacting in this market. But right now, let's see, I need increasing, so I'm going to ignore anything that says decreasing. So that means C and A are out. They both start out the same with a function notation for my input and my output. Okay, revenue is not a rate of change, so you wouldn't have a per with your revenue. So I would say at a production level of 2,100, oh, this is awful. It's 2,100 saws. They didn't include the unit in the already typed sentence, so I'm going to try to type saws in, because you got to have your unit. If you don't put your unit on a quiz or a test, you're going to get points off. So it should have had like a box and the word saws after it, but it did not. So I'm going to try to type in 2,100 saws. Might count it wrong. If it does, then I'll just take the unit off, even though that's horribly wrong and I hate that in my math lab. But anyway, 2,100 saws. Okay, and the revenue is increasing at a rate of, oh good, they got the units right, $195 per saw. So I'm going to type all that into my math lab. Yeah, it counted it wrong when I included the unit in my production level, which makes me so angry, but that's okay. So I just took the word saws out, even though we need it on a quiz or test, and then it counted it right. And now we're just going to repeat that process for 4,500 saws. So I'm just going to replace my input with 4,500, and then let's see what our calculator gives us. Okay, yeah, 75. So at a production level of 4,500 saws, our revenues are still positive. They're still increasing, but not as quickly. Later, we'll learn something called the point of diminishing returns, and that involves this concept of you're still making money. It's still positive. Your revenue's still increasing, just not as quickly as it was before. And you want to find that sweet spot. But right now, we're just practicing interpreting. It's a positive number, so it's going to be increasing, and I have to include the units. $75 per each additional saw that is made and sold. So we'll put that into my math lab. Okay, so here comes part F. I will not ask you to graph and find break-even points on test 1. However, I could give you a graph with the break-even points labeled and you'd have to interpret it. So I still want you to do this part because there's some interpreting involved, but I will provide the graph. I will provide the break-even points. But let's just go ahead and read F. It says the graph of the cost function and the revenue function are graphed on the same coordinate plane over that domain. So X is between 0 and 12,000. And remember, your cost function was linear. I can see it up here. It's a linear function. And my revenue function that we constructed was quadratic, opening down. So all of these have a parabola for revenue and a line for linear. Okay, so we're supposed to find the break-even points. You'll not have to do that on test 1. I'll show you quickly how to do it on Desmos. And then we're supposed to identify regions of profit and loss. And the light shading, so the yellow region is profit and the dark shading is loss. Well, we know that profit happens when our revenue is higher than our costs. So the yellow shading has to be where our revenue is above the cost. And that's happening in C and D. I can see my revenue, my quadratic, is above my linear function. So there's a profit there. That makes sense. And the same thing's happening here in D. But that's not making sense in A and B. They have the lighter shaded region when the cost is above the revenue. So we automatically know A and B are out. It's either going to be C or D based on those break-even points. So let me show you how to find those in Desmos. Okay, so here we are in Desmos. I've typed in my cost function and my revenue function, and I'm not seeing them here on my screen. And that's because right now my x-axis is only going from -10 to +10. And remember, our domain restriction was from x being between 0 and I think it was 12,000. It was pretty big. So let me go show you how to change that on your settings. You can just zoom out, but that could take a while. So I went to this little wrench, that's your graph settings. I'm going to come down here to my x-axis. Instead of going from -10 to +10, I'm going to go up to, like, I don't know, 15,000. Okay, and I'm still not seeing that on my graph because my y-axis is way too small. It's only going from -7 to +7. And I can see here my costs, my fixed costs are 72,000, like just in and of itself. So I need a number bigger than 72,000. I don't know. I might just, oh, you know what we could do? I mean, we could play around with this. Like I could type in 100,000 and I could see it's still not good enough. Like I can see a little bit more of my graph, but what I can do here on my graphs that were given to me. Wow. On my y-axis, see how they're going all the way up to 1 million, from 0 to 1 million? Wow. So I'm going to go make my y-axis go up to 1 million in Desmos. So I'm going to click on my little wrench again. I'm going to go all the way up to 1 million here. So 1, 0, 0, 0, 0, 0, 0. Woo. Okay, when I did that, I can see both my quadratic revenue function and my linear cost function. And then Desmos calculates the intersection points so quickly. All you have to do is either click on the red line, and you can see it automatically calculates those gray intersection points. You just have to hover your mouse over either point, or you could click on the blue revenue function, and it'll automatically calculate those intersection points in gray. So it looks like the first input would be about 310 saws. God, those are yucky numbers. And the other input would be about 9,289 saws. So coming back here to our question, yeah, D looks about 310 saws, about 200. Yep, okay, that looks good. So I'm going to check my answer. Yay, we got that one right. Okay, and then now we're being asked to find the profit function. Profit formula will be given to you on test 1. The concept of profit is just money you get to keep, right? So that's all the money coming in, that's revenue, minus all the money coming out, that's cost. So on the test, I'll give you this formula. You'll be given that profit is calculated by doing revenue minus cost. You'll just have to know how to use that formula. So here, I'm just going to rewrite my revenue formula, which was negative 0.025 x squared plus 300. And then I'm subtracting my cost function, but since it's a binomial, I need to group the entire cost function in parentheses because I need to subtract the entire cost function. I need to subtract both terms. So I'll go ahead and, distribute that subtraction in there. And then we'll combine like terms, and that'll give us our simplified revenue function. I think I forgot an X there. Yeah, okay. That'll give us our simplified revenue. Well, we'll have to combine like terms, and then we'll have our simplified profit function. Here we go. Okay. Wait, yes, profit. We're finding profit. I keep wanting to do revenue. Okay, so revenue minus costs. Cost was a binomial. I put it in parentheses. Since it was a binomial, I had to distribute the subtraction, which I did. Yes, okay. So now I'm just going to combine these like terms, and I can see my profit function right here. And this video is already like ridiculously long. So what I'm going to do is just, instead of going back to my math lab to keep entering all these answers, this is going to behave very much like marginal revenue and interpreting the marginal revenue. It's just, you're going to be using the word profit. So I'm just going to quickly take my derivative using my power rule here. And when I do that, okay, I got my power rule here. They're going to give you some inputs to put into your marginal profit formula. And you just have to remember that marginal profit is telling you how profit is changing at that production level. So if I input a number that outputs something positive, that means my profit is going to be increasing at that production level. If I input a number there, a number of saws that creates a negative output, that means that my marginal profit is going to be decreasing. It's going to be going down. You can still be bringing money in. You can still be making a profit, but it could be declining. That profit margin could be like slowly deteriorating. Like you're still bringing money in, but not as quickly. So, but that negative number tells you how the profit is changing. So your profit, I could plug it into profit and still get a positive profit. But when I plug it into the derivative of the profit, the derivative could be negative. That means the profit is decreasing at that point in time. I'm still bringing money in, but it's on the decline, if that makes sense. So if you have any questions about the remainder of this MyMathLab problem, try it on your own now that you've seen this video and it's helped you out, hopefully. Try it on your own, and if you have follow-up questions, email me, click Ask the Instructor, and we can look at your individual problem. And just remember, when you're interpreting your derivative, I need to see the words increasing or decreasing based on whether the output was positive or negative, and there needs to be a word per in there because you're comparing your outputs and your inputs. So you need to describe what's happening to your outputs using correct units, and you need to describe what's happening to your inputs using correct units. So just keep all that in mind while you're writing your interpretations, and shoot me an email if you're having trouble.